exponent problems, we'll do the kind of exponential one after, but, and this will kind of bring in a lot of the things we talked about. Just as a reminder, it's nice to have the properties, just to remind yourself, what the heck do I do if I see this happen? But once again, you can have them there as a reference, so just know where they are. So if I were starting this one, you always start where the parentheses are. So I go to the top, the numerator, right? And with this set of parentheses, I see that everything in here is going to get raised to the second power. So if I'm raising everything to the second, 2 to the second is 4. A power to a power, you need to know what to do there. You multiply, that gives you x to the 6th. And then same thing here, you multiply as y to the 8th. Now I haven't touched the bottom yet, so I'm just going to kind of rewrite it.
What is this an example of?
This is an example of the properties of exponents. I'm just going to go right down the list, okay? Now, that's what I'm saying. Okay, I'm definitely not done. I still have stuff I can combine. Once again, you know you're not done. When you see like an x and an x, you can always combine those. So you only want one of each base. So I say, okay, well now I have a division problem, so I'm going to divide. When I divide just numbers, they're just numbers. What is 4 divided by 8? 1/2. Okay. So just treat regular numbers like regular numbers, okay? Where you're multiplying and dividing. And our property says that when we divide, we subtract exponents. 6 minus 6 gives me x to the 0. We know it's going to be something, but I'll leave it for a second. When you're doing this, if you have a fraction here, you're just going to put all your answers on the top. And then if we have to flip it, we can, but if not, it's just this. 8, just be careful because it's minus negative 3 is y to the 11th. I'm just about done because the last thing I see is I have a 0 exponent. That was one of our first properties we talked about. If anything is raised to the 0 power, it is 1. Basically, you can just cancel it out, right? We don't have to write a 1 because 1 times anything is itself. So my final answer is 1 y to the 11th over 2. And you know what, even actually, once again, 1s are kind of like disposable. You don't really need them unless there's nothing there. So you could write it like that, or you could have the 1 in front, either way.
I have a question.
Yes, sir.
So, when it's like, so how do you know, I don't know how to explain this.
Okay.
So just say it's like x6 over top, then
Yep.
x4, and obviously it would be 2.
Yep.
So why do you put it on top?
Because you would only put something on the bottom if you had to flip it.
Oh, alright.
Because remember, it all goes back to just something being negative and having to flip, you only put it on the bottom. So that's why I just put everything on the top, and then if I see a negative, I flip it to the bottom. That's it. Any problems with the first one? We're just gonna do one more property one. We're not gonna like kill ourselves on these because we have a bunch of other stuff. You have a lot of examples of properties of exponents, so use them. You've taken open note little quizzy thing. That was last week at some point. I did give them back to you. So you might want to check those. There. So let's do one more. I'm just trying to do some different properties we did. I'll do one that I know that I see the most mistakes on. Okay. What else was other people doing? Okay, so let's do 5 x to the 3rd y to the negative 2nd times negative 3 x y to the 11th. So between that one and the first one and the second one, it kind of is all the properties, just in different little cases. Hey, everyone, where should we start?
Oh, where without being parentheses.
You're supposed to all yell it in unison, but that's okay. You're supposed to do parentheses, and I was going to get really excited, but it's okay. Parentheses, okay? I know, it's okay. We'll work on it. Once we come back as a class, we'll work on, being more in unison. So we start with parentheses, no matter what, you always start with parentheses. And with parentheses, I say, what can I do to it? Well, I can raise everything to the negative 2nd power. So I'm going to write that as 5 to the negative 2nd, because remember, Doesn't make the number negative, it means I'm gonna have to flip it in a few minutes, but I'll just kind of keep it like that for now. And then I get x to the negative sixth and y to the negative second, because remember there's a 1 there in the variable. So now I'm taking that and I'm multiplying it by negative 3xy to the 11. Here's where it can get a little tricky, so you just need to be careful. I try to kind of keep combining because I see x's and y's that I can put together. The numbers are usually where people get messed up. So here's what I do to kind of organize. I'm going to write 5 to the negative second. And I'm just going to put this times negative 3 also on the front. I'm just going to put the numbers in the front. I'm not doing anything with them yet. I'm just kind of moving them together. Yeah.
Where the 5 is that 5 negative 2?
Yes, to the negative 2. Now I can combine my x's. I'm adding the exponents. That's what my property says with multiplication. We add exponents. That would give me x to the negative 5th. And that would give me y to the 9th. So it's still looking weird in the front, right, with the numbers. And that's usually, once again, you guys are really good at doing bases, like x's, y's. The numbers are what kind of freak us out. Remember what our property says. Our property says if we have a negative exponent, which we do here and here, we're going to make a fraction and flip those. Okay, so let's just do that. If it's not circled, it stays. This negative 3 does not flip. Don't flip it because there's a negative in front. I only care if there's a negative exponent, okay? So negative 3, don't touch. Y to the 9th stays where it is. I flip 5, so now that's just regular squared, because when you flip it, it turns positive. And x to the 5th. And my last step, I know what 5 squared is, so I just simplify that. It's 25. And that, my friends, would be your final answer. You can see where kind of like the numbers in front get a little tricky. So I always kind of just keep things organized, but keep them separated. If there's a negative exponent, that means that's my last step. I kind of flip it. If it's just a number, you just keep it. And then you do your best to simplify from there. So I'll leave that one up for a second. Excuse me. Does anyone right now have any questions about the properties of exponents?
No.
Wasn't that just great? So know them, love them, you got them in your notes, just know where they're. The big thing about a notebook quiz, is there anything worse than when you're taking a notebook quiz and someone in your class gets like aggressive with it, and then they're like, all you can hear is this. And then like there's people freaking out the whole time. Don't freak out, okay? Have your stuff organized, put it in one spot. Then you won't have to like be flipping through 8,000 notebooks. Now, there was one other property that we kind of did a little bit, not separately, but we did its own thing with. And that was the property that, where the exponent was a fraction. So if I said y to the 3/5, and I said write this as a radical. One, you need to know what a radical is. So that will be sad if you don't know what that is. A radical just looks like a root, okay? Just a fancy word for it. You just need to know where things go. And once again, if you have a few good examples, you'll be in good shape. But just as a reminder, your base goes underneath. The numerator stays as the exponent to that base. And the denominator goes on the outside of the root. So that's what it would look like in radical form, just as a reminder, because it's been a while since we did that one.
Oh.
You can also go the opposite way, and this is where your calculator is going to come handy. If I say write in exponential form, aka we're going to write something as an exponent. I'm actually going to grab my calculator so I give you a nice number. Let me see. And I'm going to say the 5th root of 1024 x to the 4th, y to the 9th. So if I say write the exponential form, you're saying, oh gosh, I need to go from this radical, I need to make things exponents. How do I do that? Before you start, just make sure everything has an exponent. So y is all said, it's to the 9th, x is to the 4th. Even 1024 needs an exponent, so I'm gonna put that to the 1st, just to remind myself. Every base needs an exponent. So then you take the base, you take the exponent that's with it, and then each of those you now make a fraction and put it over 5. So base, exponent over 5, base, exponent over 5. Okay, so you kind of see the pattern going on. Now here's the thing, when you do this, it will say simplify all the way. You need to figure out what this is. So this is where your handy dandy calculator is gonna come in. So right now, try it. 1024, raise it, so I call it the caret button, it looks like it's kind of being raised up. And then I always make sure I put the 1/5 in parentheses, I'm parenthesis happy, I just make sure everything's good. So 1/5. I'll try to make them nice numbers, so if you get a weird decimal, you did something wrong. It should come out to be 4.
Wait, can you do that with the calculator again? I don't know.
Yep, it's just 1024.
Yeah.
Then find your raise to the exponent, whatever,
Yeah.
like, mine's my little caret, and then put in 1/5. I usually do it in parentheses, but just try it on yours. Every calculator is different.
So is it always gonna come out to a whole number?
I'll try to make it, I will try to make it a whole number.
My bad.
So if you get a decimal, probably you did something wrong, because I'll make it a nice number for you.
That's the worst one I've ever heard.
All right.
Is that X to 4, like 4/5?
Do you want to move up then?
No, it's just that you wrote it so small. Actually, yeah, I want to move up.
I remember when we got new seats, because guys, when everyone's here, we're gonna have way more desks, everyone's gonna have to move around. So we'll get new seats.
Is it still gonna be singular then?
Yeah, it'll still be. Still be rows, everyone facing forward, can't move them. But there'll be more, so everything will be shifted. And obviously, people in cohort A and cohort B probably sit.
How far do you think these desks are?
4, 5.
I think there'll be like a whole other row. So if there's 3 right now back, I think there'll be 4.
Dude, what is this desk?
Oh, those are the old
Oh,
ones.
somebody spelled Andrew wrong in my desk, so that's cool.
Yeah, we gotta put someone's name, at least spell it right. Alright,
Andrew.
so let's try this one. Now, this is also where your calculator is gonna come in handy, so just keep this in mind. If I said simplify this, AKA combine this, I'm gonna say x to the 2/9 times x to the, I don't wanna do that. X to the 3/5 times x to the 4/7. You do not wanna do that in your head, PS. And then I'm gonna say, write your answer as a radical. Do you have a question?
No, never mind.
Okay. So 1, you are now no longer a person that sees a fraction and goes, oh, I hate fractions. Because you say, oh, fractions aren't that bad, I can just use my calculator. So you just need to know the rule. If we see multiplication, please do not multiply them. The properties of exponents are still in play. You are going to add all of these. So I don't mind this problem because I'm just going to do it with my calculator. So I take my calc. I put 2/9 plus 3/5. And I just do it right in a row, plus 4/7. Why not? Just do it all together. Now, reminder, if you get a mixed number, it says 1 and then a fraction, know how to change it. I believe you hit, a lot of the times you hit second and then the fraction button, I think again, or shift and then the fraction button. Try it now. I don't know what you hit,
Are
so
we doing 2/9 plus 3/5?
Wait, is it 1 over
plus the extra.
124 over 315?
Yes, but that you don't want it as a mixed number, so for you hit shift and then hit the ABC button. Shift is at the top left, with the yellow, and then the ABC button, and then it should make it you always want improper fractions, you don't, it would be weird to have a mixed number. But it should, it comes out to a weirdo answer, x to the 439 over 315. But they did ask us to write it as a radical, so I just need to know where things go at this point. So under my radical, we would have x to the 439, and then outside of my root, I would have 315. So that's the answer I would be looking for. And then there's one other type of problem. P.S. I'm doing these ones for a very specific reason. I know there's ones like this on the exam. If anything I'm doing today, I'm doing for a reason because I know it's on the exam. Because I made the exam.
What?
What are you talking about? Hold on, I'm just trying to find numbers that aren't gonna be terrible for you.
It's just like a yard sale desk.
No, those were in the old, so those desks were in the old school.
How far back?
They're pretty old,
So I could be touching someone that's dead.
No.
pretty much.
Well, anyone,
I mean, someone could be dead.
Yeah, so yes.
maybe.
Sorry, I'm trying to make this nicer. Okay.
Andy.
So, my friends, there is a problem like this on there. It's going to say write in exponential form, then simplify. When we see things in radicals, they're just a pain. You don't really ever want to deal with radicals and trying to combine things. So what we're going to do is make them exponents, because we know how to deal with exponents. And then once they're in exponential form, then we can combine them. So when I say make exponents, just change the form. If I have the third root of x squared, I can write that as x, keep the exponent, and then remember if there's a 3 out here, I put that over 3. And then here I would have x to the 5th, and I would put it over 11. And I would say, oh, I can combine those because it's a division problem. With a division problem, I'm going to subtract exponents, and with fractions, I can just use my calculator. So I just grab mine, 2/3 minus 5/11. What's that going to be? X to the 7 over 33. And then it just says exponential form, so you can leave it. You don't have to do anything fancy from there. So just always read directions about what form you need it in. But I know for a fact there's one of each of those, so I didn't want to point those ones out. So I'll take a little breather for a second here, so you're getting caught up. Or if you have any questions, feel free to ask.
Honestly, I think they're from like H&M or something.
Oops. All right, so that's all like the rules, properties, all that fun stuff. So then the next thing we went into was the exponential function, y equals ab to the x. So I'm telling you right now, I forget which day we did it. I think we started it Friday, we finished it yesterday. There was a worksheet. I would have that worksheet. If you have that worksheet, that's all the exponential function stuff. So just
The one that we did in the Auditorium.
we finished it yesterday.
Oh, yeah.
With the, remember that like long formulas on the end, we had started on, wait, what's today? What, Thursday?
Thursday.
We
Are
started,
you okay?
no, I don't know what day it is.
He's having a breakdown.
I can't
Wait, so can we
remember.
bring that?
But maybe we started Monday. I think we started Monday.
No,
Yeah, we did. We started.
Wednesday.
We didn't start Wednesday, I know that's a
So
lie.
we started Thursday.
Monday.
I'm pretty sure that's also
Friday?
a lie.
Of 2 weeks ago.
Saturday.
I don't even know.
January 1st.
We started at some point. It said 7677 worksheet or something. It has all the function stuff, so.
Oh.
I would have that with me. If I were taking the exam, I would have that. So let's just do like a quick reminder of the things that we need. And
So, can I just use this?
yes,
I know.
okay, well, I don't, when I say notebook quiz, you could use anything in your, like, anything. Well, not
Google?
anything, anything you've written on. So you can use a worksheet, you can use notes.
Google Docs.
All right, exponential functions. They have the form y equals ab to the x. And the big thing that we needed to remember is x is the exponent. So that's the main thing for exponential. X is the exponents. And the first thing we started with was kind of graphing, like what do exponential functions look like? We have a general idea of what they look like going in, but we should be able to graph them. So if I said, hey, I'm going to give you this exponential function and I want you to graph it. 3 times 1/3 of x. So remember, like human nature, we tend to want to like multiply 3 times 1/3. You can't do that. Okay, it's against the order of operations. You keep them separate. I will kind of set it up for you tomorrow. I'll give you a little chart. Your x's will be filled in, I think. I'm pretty sure. I'll make sure. If not, I'll remind you.
Thanks.
So that will remind you, oh, I need to just find those y's. And then then there's like a little setup of a little graph over here. Then I'll just do a quick sketch. It will say, just as a heads up in the directions, all output should be left as reduced fractions. So I don't want to see decimals. So just as a heads up, this is one I'm still using my calculator because why not, right? Gonna do the work for me and go from there. So remember what I'm doing. I'm just taking my equation and I'm plugging -2 in for x. So this first one, I'm going to type 3 times 1/3 raised to the -2nd. So try that now, see what you get, because I have no clue what it is.
27.
It is 27. Lovely, thank you. Make sure you're getting 27. Then you basically just keep repeating that step. Right now, I'm going to plug in -1. You should get little 9ster. Then I'm going to plug in 0. I'm going to get 3. I'm going to plug in 1. And I should get 1. And when I plug in 2, I should get 1/3.
COVID.
Know how to convert a decimal to a fraction on your calculator? I forget how to do it on this one. Let me check quick. Oh, helps when you turn it on, Mrs. Sherman. There we go. Okay, also helps when you hit the right buttons. I don't even know how to do it on this one. Second something. Oh, if I hit second fraction button, it does it for me. I know on some of those other TI ones, you hit second something else. It looks like FD. If you don't know, just ask me. But make sure if you get a decimal, make sure you know how to put it into a fraction. And then we're just plotting these points. And once again, it's a sketch. It doesn't have to be anything too fancy. Just the general shape. I need to go up to 27, so choose an appropriate scale. I'm going to go 5s. 5, 10, 15, 20, 25, 30. Make sure I can actually know, I actually know what your scale is. Don't just like kind of put tick marks and assume I know what the heck you're doing here. And then we're just doing some quick, okay, this is about right here. This is about right there. And we got right here, right here. And obviously the fraction ones, you just kind of go as low as you can. But we've seen this general shape before. We call it an asymptote. Kind of approaches that but never crosses it. And we should have actually known this was a decay before we even started because the base is less than 1. So we should have known it was going to be decreasing. So just some things to think about, but you will have to do just one sketch on the exam. I'm out of time. Oh, what's up? Mhm. So yeah, whatever your base is, so since your base is 1/3, that's what you're doing, you're just taking a third, right? Yep, so if your base was 2, you could double it, but yep, that's it, if you wanna do it, that's just the weight one. Just depending. Yep. Yeah, yep, it's the same thing, whatever works for you. But yes, that is a nice pattern to see. BUTS. So then we said, okay, we have a general idea of like exponentials, we kind of know what they look like now. And then we talked about stuff like this. If I gave you an exponential function, y equals 92 times 1.26 to the x power. It's gonna be okay, take a deep breath. And I said, hey everyone, is this a growth or is it a decay? What would you say?
Growth.
You would say growth, because once again, I don't even care about this number in that question. I only care about this, and if it's greater than 1, it's a growth. And if I said, what is the growth factor, which basically just means what's the percent, okay, just we're using like proper terminology here.
Oh.
If I said, what's the growth factor, or by what percent is it growing, does anyone know what that would be?
I have a question.
Yeah.
So if it's 1, then what? Is that greater or?
If it's 1, then it's doing nothing, it's just staying the same.
Oh yeah.
Does anyone know by what percent it's growing? Could someone give me a guess?
26%.
26%. So we had written quick little notes the other day, so once again, that's something you might want to look at. If it's a growth, to find the percentage, you do the base minus 1, right? So if I did 1.26 minus 1, I end up with 0.26, and then you move the decimal to get the percentage. So you might want to make sure you have that somewhere. So to find percent. So if I gave you something like y equals, I don't know, it's on the screen here, yeah. 56 times 0.91 to the x. Growth or decay?
Okay.
Decay, because the base is less than 1. By what percentage am I decaying?
91.
9%.
It's 9%.
To stay.
Nice. Now, the reason being, all of our measurements are always done from 1. We're just saying how high, like how much above 1 or how below 1 are you? That sounds right. So for a decay, you always do 1 minus the base. So if I did 1 minus 0.91, I would get 0.09, and that's where the 9% comes from. So P.S. If you didn't know that, write it down now, and then you can know it tomorrow when you have to tell it to. Okay, so all of our measurements are just done from 1. How high above 1, how low below 1 am I? But don't see 0.91 and say 91%. No, 91% would be a 0.09 base. So I'll leave that up for a second in case you need it, because that's something we've done more recently, and once again, it was on that worksheet, so the worksheet will be your friend. I'm so hungry. All right, then 2 just other quick things. And one is based off of this kind of concept. I just erased the thing that I needed. Oh, this was Sherman. Yeah. I would say write an exponential equation. So you're gonna write one. And just as a reminder, it has the form y equals a times b to the x. And I'd give you some scenario. The number of elephants at some park, I don't know, are increasing at a rate of 4% per year. if there are, 26 at this wildlife refuge, we'll say, if there are 26 elephants right now, how many will there be in 6 years? Write that one out, man. All right, so there'll be something of this sort. There's, elephants. We talked about the other day. There were turtles. I don't know. You can talk about all different stuff. But we have something that's increasing at a certain rate per year, and we have how many there are now, and then we want to know how many there are eventually. So the nice thing about this equation is it's not super long. We don't have to plug in a ton of stuff. Just hitting things on my phone. The first thing I need is the initial amount. Well, we're starting with 26. So I would start with y equals 26. So how many are you starting with? Now my base is based off of two things. So you look whether you're increasing or decreasing, and by what percent. Now think about it logically. If the base is 4%, and that's 0.04 as a decimal, I can't just put 0.04 here, right? Because 0.04 would be a decrease because it's less than 1. So what do I put here if I'm increasing by 4%?
What did,
1.04. Right? So you just need to remember, increase, it has to be a greater than 1, so you just add 1. Does that make sense? Remember, if it was a decrease, you would do 1 minus whatever you're decreasing by. So if it's at a decrease of 4%, once again, don't put 4%, you would do 1 minus 0.04 for 0.96. So just as a heads up. And then since we want to know 6 years, we'll raise it to the 6th. This is another problem. You can't do it without a calculator, so please have one. 26 times 1.04 raised to the 6th power. We're going to round to the nearest elephant. It came out to 32.89. So we'll say about, you usually put the curly equal. About 33 elephants. Oh, good. So once again, there's a few examples of those on that worksheet. So have the worksheet. Good, would be easier. All right, one more problem. And what timing on my part?
I have a question. Did you just say
So
33 or about 33?
About 33. So when you put when you make an equal sign, but you make a little curvy, that means approximately. So you can do that or say about.
I wouldn't remember that.
We're not being too sick. All right, the last question has to do with the compound interest formula, which I will give to you, Pia, and you also have it on that worksheet. But it's right in the directions for the problem, or there's 1 or 2 problems on it. So the formula is A equals P1 plus R over N, raised to the N times T. What a beauty. And as you read through a problem, you just need to know, well, what goes where? Because I like formulas. You kind of just plug into them, and then you're kind of done. So then we'll plug in, throw in the calculator, that'll do that. So if I say I deposit $1,200 in an account with a rate of 3% compounded monthly for 5 years. I might be a little bit more formal tomorrow, like actually writing complete sentences, but you get the idea. So we have all this info, we just need to know where each thing goes. When I'm talking about what I'm depositing or what I'm putting in, that's my P. So P means principal, that's how much you put in, so 1,200. When I'm talking about rate, that's your percentage. It's right here, rate. Just make sure your percentages do get written as decimals, so we're gonna write it as 0.03 when we plug it in. The word compounded, so that's what our N represents, the number of times it compounds. So it's usually a key word with it. And when I say monthly, that means that happens 12 times per year. I won't give you anything crazy. Monthly, quarterly is 4. Semi-annually is 2, annually is 1. I think that's about as crazy as I would get, but if you have a question, just let me know. And then 5 years, that's T. So I'm a labeler, I like to label first, just so I know what's what, and then I'm gonna plug it into my formula. A equals 1,200, 1 plus, so the 1 plus is always there because we're always gonna be earning money, so that's the whole reason. We always want an increase. 0.03 over 12, and then we're gonna raise that to the 12 times 5. So there's not a lot of work that goes into these necessarily, it's just knowing what goes where. And then please make sure you test this one on your calculator. So make sure you know how to plug it in. I'm gonna do it in mine, we'll kind of get the answer and make sure you're getting it as well. If you see parentheses, use parentheses. That's my biggest hint to you. Okay, calculators get mad when you tell them to do the wrong things, or I get mad when you tell them to do them. And please, don't give me about they're gonna make like $89 million. Like, that's just not logical. Like, you know, he'll make a little bit. In the end, he should make he should have $1,393.94. We'll go to 2 decimal places since we're talking about money. Make sure you can get that on your calculator. If you can't, let me know. Because we only have about a minute left. Oh. What did you say? Okay. What type, do you have like a, what's up, calculator yet? Oh yeah, like the basic one. So when you're putting it in, put your 1,200, do your parentheses. Sometimes the calculator gets mad at you if you try to use the fraction button on these. So if you're like getting something on that, try to just do divided by
I
it.
love doing that, just taking pictures of everything.
So try that, and if it doesn't work, no, it's not really fun.
Listen, joke.
Hey,
It's
everyone,
a joke.
quickly. If the total amount after 5 years is $1,393.94, if I asked you, how much did this person make in interest over that time, what would you say?
None of your business.
That's not what I was gonna say.
Somebody's
If
finances is their own business.
he originally put 1,200 and now he has 1,393, that means he made $193.94. You just subtract the original amount off. If I just brought that up with 30 seconds left, you should probably know it. Yes. So anything we did today, you're basically gonna see tomorrow. I'm not gonna try to trick you, but just come in organized and you should be in. Wait, oh, look at me, like a bell.